you to understand, right, the concepts in your core paper, right? So attend the class regularly, that is one thing. And the other thing, not only attending, simply giving attendance, right? You have to study something and then you have to produce that thing in your CAT papers and as well as in the assignments. Anyway, right, without wasting time, because I do not waste time, right? So I will move on to the subject. Last class we have discussed that solving higher order PDEs. In that there are several cases are there. So we have seen the case that is the right hand side. We have exponential function. Right now today we will see the other things. Right. So just recall whatever we have seen in the last class, and then I will move on. Right. So now I share my screen. Okay, is my screen is visible to all of you? Is my screen is visible? Whether my audio and video is okay? Whether my audio and video is okay? Somebody reply me. Okay, right. Right, so last class we have discussed solving higher order PDEs, that is degree 2 or degree 3. Right? So a typical example for a second order PDE is, you can see in the screen, that is dou square z by dou x square plus dou square z by dou xy. So this is a second order PDE, right? And here this is called a linear PDE, because here the coefficients are only the numbers, right? And it is a homogeneous one. That is, if you see the order, right, all the terms having the same order, that is order 2. Not only that, right, right, so homogeneous differential equation means the order of the equation should be same in all the terms. Suppose you can see in example 10, okay, it is the third order differential equation, and you can see the third order d cube, then d square d dash. This is also a third order one. Why? Because here you have to differentiate 2 times with respect to x and 1 time with respect to y. And here again d dash square, that is you have to differentiate 1 time with respect to x and 2 times with respect to y. So all these 3 terms are having order 3. So it is a homogeneous linear partial differential equations. And last class I explained you how to solve the problem for the complementary function part. So complementary function part means, I think this problem we discussed last class, right? So what we have to do now, we have to take only the derivative part, right? And there you have to substitute, in place of d you have to substitute m, in place of d dash you have to substitute 1, and then you have to write the auxiliary equation, and you have to find the roots of the auxiliary equation. And then I explained you how to write the complementary function in the last class, right? That is one part. Then the other part is finding the particular integral. So in finding the particular integral means you have to see the right hand side part. So when you write the complementary function, you have to take the right hand side as 0. You have to take the right hand side as 0. To find the complementary function, you have to assume the right hand side as 0, and you have to find the complementary function. But that is not the end of the problem, because you have the right hand side also. So that you have to find as the particular integral, right? So here there are 2 terms are there. So you have to find particular integral 1 and particular integral 2. Particular integral 1 and particular integral 2. But how to find, that also I explained in the last class. Whenever the right hand side we have an exponential function, right, in e power ax plus by form, e power ax plus by form, right, then we can write the particular integral as 1 by whatever the term here, we can write the same term here, and then we can write this term e power x plus by format, e power 2x minus y here, and then we have to substitute d as the coefficient of x. Coefficient of x means here it is 2, right, and coefficient of y is minus 1, right? Coefficient of x is 2 and coefficient of y is minus 1. So by substituting d equals to 2 and d dash equals to minus 1, we will get some number in the denominator, right? And then that will be the answer. That will be the answer that we have seen in the last class. today we are going to see the same problem, right, with a special case whenever we substitute d as a coefficient of x and d dash as a coefficient of y, if the denominator becomes 0, then what we have to do? If the denominator is non-zero and you are getting some number like this, suppose for example last class we solved this problem and you are getting by substituting d equals to coefficient of x, that is 3, and d dash is the coefficient of y, that is 4, right, and you substitute, you get some number in the denominator, then that will be the particular integral. Then the solution is nothing but complementary function plus particular integral, right? So this you have seen in the last class itself. The solution is nothing but complementary function plus particular integral. But today we are going to see in the right hand side, if when we substitute d equals to a and d dash equals to b, that is coefficient of x and coefficient of y, right? If the right hand side, if the denominator becomes 0, then what we have to do? Do, right? So there are several methods are there, right, to tackle this, right? So one of the method is, Jivagan, you mute yourself. Otherwise I mute you, right? Right? So there are several methods are there. One of the method we discussed in the offline class. There is a straightforward formula is there, directly we can substitute, right? For that we have to write the denominator in factor form. So what is the meaning of factor form, right? So you can see here m square minus 4m plus 4 equals to 0, right? So that can be written as m minus 2 the whole square. So now this is called a factor. Since 2 is the root of the equation, m minus 2 is the factor. Since 2 is a root repeat twice, then m minus 2 the whole square is a factor, right? If you say, write the same factor in d terms, then you get d minus 2 d dash whole power 2, right? See, the same thing can be written, can be written like this. Why? Because what you did, when you start the problem, when you write the auxiliary equation, you put d equals to m and d dash equals to 1. So once again, after writing in terms of factor, again you have to turn back into the factor form, right? You can substitute in place of m, you can substitute d. This is 2 into 1 constant, so you can put d dash. If you expand this, you will get this original function. You will get this original function. What is the idea, or why we do like this? Why you have to write the in factor form, right? If you write the denominator in factor form like this, d minus 2 d dash the whole square in place of like this, right? So in place of this, if you write like this in factor form, and we substitute here d equals to 2 and d dash equals to 1, because d is the coefficient of x should be d and coefficient of y should be d dash. Then also we'll get 0. 2 minus 2 into 1 is 2, 0, right? Then what you have to do now, so in whatever manner, whether we write in equation form or in the factor form, we will get 0. But what we can do now, here we can directly write this as, since the denominator is 0 and we are writing everything in factor form, and the power of this factor, this is the power of the factor, right? So in this factor, d minus 2d dash, if you substitute this d value and d dash value, it becomes 0, right? So, and then we have to check the power of that factor. If the power of the factor is 2, then we can multiply straight away x square by 2 factorial, x square by 2 factorial, and then write whatever here. What is here? E power 2x minus y, that you can write here. That will be the solution of the problem. This is one shortcut method, right? Only thing, we have to write the denominator in factor form and check, right? When we substitute the values in that factor, whether the factor become 0 or non-zero. If it is non-zero, no problem, we can directly substitute. Suppose when you substitute instead of 2, 1, it is 3, 1. Then we'll get some non-zero number here. We directly substitute here and we finish the problem. Suppose when we substitute here, the denominator become 0, then we have to check the power of the factor. If the power is 3, then we have to multiply x cube by 3 factorial. If the power is 4, then we have to multiply x power 4 by 4 factorial. If the power is 1, suppose it is simply d minus 2d dash, then we have to multiply x by 1 factorial, right? So that is one thing is that. So the condition is whenever if you write in the denominator in factor form, right, and this is a factor form, that is all these things factor form, and you have to check the power of the factor, right, and when you substitute d value and d dash value here and it becomes 0, then we have to multiply the term with x power r by r factorial, x power r by r factorial, right. This is one way to solve the problem whenever the denominator becomes 0. But in this book, there is another way also given. In Virurajan, that way is given, but in this book, the another way is also given. That I also explain with 1 minute, right? So what you have to do now here, just you write the equation, right, and try to substitute, right? So when you substitute, it becomes 0. Then what you have to do now, you just differentiate this term one time with respect to d. I'll multiply x in the numerator. So that is the condition. Multiply numerator by x in equation 1. Multiply numerator by x and differentiate the denominator. dr means the denominator with respect to d. With respect to d means d square. Just like x square, it is d square. If you differentiate, it becomes 2d. Then minus 4d dash. There, if you differentiate, it becomes minus 4d differentiation 1. D dash is there, so that comes here. Then 4d dash square. Here there is no d term. You are differentiating with respect to d. So in that case, d dash is something like a constant, right? So it becomes 0. So here, what is the alternative method? One method is directly return the denominator in the factor form and checking the power of the factor and then multiply it with x power r by r factorial. That is simple one that we have seen in the class also. But there is another method also there. You have to multiply x in the numerator and differentiate the denominator with respect to d, and then you substitute. That time, if it is 0 again you have to repeat the same process. See, here also the same thing happens. Because why it happens? No, because the denominator factor is 2. So definitely we need x squared term. So one time we substitute denominator 0. So we will multiply x and then we write this. And now once again we substitute d equals to 2 and d dash equals to 1. Again it becomes 0. Then again what you have to do? Again you multiply another x with this x. Then it becomes x square. Then it becomes x square. And now you differentiate 2d. If you differentiate 2d, you will get 2. 4d dash 0 because we are differentiating with respect to d. So now we get x square in the numerator, 2 in the denominator, and e power 2 per x plus y is there. So this is the solution. So in this alternative method, the methodology is, right, once the denominator becomes 0, you have to multiply d in the numerator, x in the numerator, and you have to differentiate the denominator with respect to d one time. Then you have to substitute the values. If the values are coming in non-zero, okay, you stop. Otherwise, again you repeat the same process. Again you multiply another x in the numerator. Again you differentiate the denominator with respect to d, and you get a nice number here. So here also no need to substitute because there is no d here. So only if a constant is there, then you can write the same term here. So this is the particular integral value. This is the particular integral value. Once you find the particular integral, you can simply write the solution is nothing but the complementary function value. What is the complementary function? Plus the particular integral. So the solution is nothing but complementary function plus the particular integral, right? And this is called the general solution of the given PDE. So the general solution is nothing but z equals to, right, complementary function plus particular integral. So it is a relation between independent variable and dependent variable containing the arbitrary functions. Since the given PDE is of order 2, it has 2 arbitrary functions. So this is a general solution. This is a general solution, right? So in this manner, if the right hand side is exponential form, right, you have to work it out, right? Now we will see the next thing, that is right hand side in trigonometry form. Right hand side is in trigonometry form, right? So that I will can an example, right? So you can see an example, right? Dou square z by dou x square. So dou square z by dou x square means that is nothing but d square. That is differentiate z with respect to x 2 times. Then dou square z by dou x dou y, that is dd dash. And dou square z by dou y square, that is d dash square. That is d dash square, right? So d square plus dd dash. So the same term they are writing like this. By taking z outside, this is the differential operator. D square z means differentiate z with 2 times. and d dash square of z means differentiate z with respect to y 2 times, and d dash of z means differentiating z 2 times with respect to x 1 time with respect to y another time, right? Now the right hand side is trigonometric function. So now the methodology is different. But first finding the commutative function is same, right? Only when come to the particular integral, we have a different thing. But uh, you, for commutative function, it is same. So in commutative function, we simply write this term, right? Z no need, right? Only this term we have to substitute d equals to m and d dash equals to 1, and we get a nice equation, and we are getting two roots, right? Minus 3 and 2. Remember, this is also called as factors. M plus 3 and m minus 2 are all factors, and this can be written as d plus 3d dash. This m factor can be written in terms of dd dash like this. This is equivalent to this. When we transform again in terms of dd dash, we can write this term as d plus 3d dash, and similarly we can write this term as d minus 2d dash, right? So that is writing in factor form, right? Because that will work certain times, right? But here it's no problem, right? Straight away you're getting the two roots, and this is the way of writing the commutative function. Since minus 3 and 2 are roots, you have to write phi 1 y plus first root. First root is minus 3. So minus 3x plus phi 2 y plus the second root, that is 2x. So this is commutative function over. There we assume the right hand side is 0. But original function, the right hand side is not 0. It is cos 3x plus 2y. So now what you have to do now, you have to put cos 3x plus 2y in the numerator, and you have to write this term in the denominator, just like in your exponential function, right? So now here how to substitute. Previously in exponential function, we take the coefficient of x and coefficient of y. Here also take same thing, you have to take the coefficient of x and coefficient of y, but here we have to substitute only for d squared terms, not for d terms, right? But luckily we have only second derivatives always, right? If there is any single derivative like plus d or minus 6d dash only, then we can't substitute. So here the rule is you have to substitute only for d squared term or d dash squared term or dd dash. All three things are second derivative. This is second derivative with respect to x, this is second derivative with respect to y, and this is second derivative with respect to x and y, right? How to substitute? That is very, very important. In place of d square, right, you have to substitute minus. Remember, you put minus first, and then you have to square the coefficient of x. What is the coefficient of x? 3. That you have to write. So 3 square is 9, right? So remember, you are putting minus sign first, then you have to squaring. It is not minus 3 the whole square. If it is minus 3 whole square means it become plus, right? But it is not like that. It is minus, right? This term, coefficient of x, suppose you take it as a square, that is 3. Similarly, for next term, d square term, d dash square term, for d dash square term, you have to write minus the coefficient of y. What is the coefficient of y? 2. So 2 square is 4. And similarly for dd dash term, you have to put minus sign, and then you take coefficient of x one time and coefficient of y one time. Right? Previously it is 3 square, then 2 square, but now for dd dash it is minus of 3 into 2 minus 6. Right? So you have to substitute the value here, and if you are getting a nice number in the denominator, then problem will over. You can straight away write z is nothing but the complementary function, that is this, plus the particular integral is this. Complementary function plus particular integral, right? So this is the way, okay, we can solve the problem. Very simple, straightforward one. But remember, you have to put only for d square term, dd dash term, and d dash square term. Only for that only you have to substitute this minus of coefficient of x value square, and for d dash square you have to put minus of coefficient of y value square, and for dd dash you have to put minus of coefficient of x into coefficient of y, right? Then straightforward value you can get, right? Suppose if it is not there, right? So hereafter I don't want to read the problem right from the beginning. So hereafter I will skip the complementary function part. I will just explain only the particular integral part, because that only the different types are coming, right? So now you look at this problem, right? So here it is a third order problem. See, it is d cube d square d dash plus 4d d dash square. So everywhere the order is 3. So definitely you have a third degree polynomial. So you have 3 roots. So here we are getting 3 roots, 0, 2, 2, and in such a manner they can write the complementary function also. So in that case it is no problem, right? But particular part is very, very important, because I already told, right, you can substitute only when for d squared terms. But here in the denominator, right, here the order is 3. Here also d square d dash order is 3. Right, here also d dash square order is 3. Right. So don't only look at only 1 minute. Only 1 minute. Jason? Okay, we'll ask at the time of attendance. Jason? Right. So can you see my screen now? Can you see my screen now?
Yes, sir.
Okay. Right. So anyway, right. So here the problem is, right, it is everything in third order, right? Don't think it is d square here, right? You have to consider the whole term. So as a whole term, it is a third order term, d square d dash, right? So don't think, sir, here d square is there, we can substitute for here d square, not like that, right? The as whole term, it is a third order term, and this is a third order term. So only 1 minute. Hello? Right. Right. So here, what you have to do now, we have to take in this d cube term, we take one d outside, right? So if you take d outside, right, so automatically here we get d square term, and here you get one d term, and then d dash is as it is, and here we can, once we take d out, it will only d dash square, right? So now we can see here d square, d dash, and d dash square. Okay, now here you can substitute, but you can't substitute for d, but you can substitute for d square term, d dash term, d dash square term. The coefficient of x, that is 3. So here you can substitute minus 3 square. For d dash, you can substitute the coefficient of y, that is minus 6 square. And for d dash, you can substitute minus of coefficient of x and coefficient of y. Coefficient of x and coefficient of y. That is here and here. Then you will get a nice term minus 81, right? But this is not the end of the problem, right? Because the d is in the denominator, right? What to do, right? Now you have to understand one simple thing, right? Now you have to understand one simple thing, right? You since d term, right, is called as the derivative, then 1 by d can be called as the integral operator, right? If d is called as the derivative operator with respect to x, then 1 by d is called as integral operator with respect to dx, right? So since the d in the denominator, so it is something like sine 3x plus 6y divided by d. So 6 by 81 is a number, right? So that you can write minus 2 by 27. Then 1 by d means, if suppose the denominator, if the d in the numerator, then you have to differentiate sine. Since d in the denominator, you have to integrate sine, right, with respect to x. then you will get integral of sin s cos, sorry, minus cos, that is minus cos 3x plus 6y, and since you are integrating with respect to x, you have to write the coefficient of x in the denominator. This is simple integral formula. Integral of sin ax is minus cos ax by a, right? That a is in the denominator, right? And then you can write the answer, right? So here the important thing is, if it is not in d square form, if it is not in d square form, right, we have to make it in the d square form, and then we have to solve it, and then we have to solve it. There are several problems are there, right? You can work it out on this, right? So here also some special cases comes, right? That is, whenever we did the substitute in the denominator, whenever we substitute in the denominator, sometimes it also becomes 0. It also becomes 0, right? So for that I will take this particular problem, right? So again and again I neglect the complementary function part because that is very simple. You just find the roots of the equation. Here the roots of the equation are 1 by 2 and 2. So just you write the complementary function. Just you can write the complementary function, right? Who is coming now? Vijay Kumar and where they gone? Jason and Vijay Kumar. Jason,
Sir,
why you joined so late? Don't you know the class is 12:20?
previous class was bit late, sir.
Hey, previous class, other people joined it by 12:20. Why are you telling previous classes up to 12:40?
Then you didn't allow me, sir.
I allowed everybody up to 12:20, 12 up to 12:30. See, only thing you should not miss the class. For that only I am allowing you, right? Because the class is only 2 hours, only 2 days class, right? So that I am allowing you uh, uh, to join in the class, right? But you should join in the class at least 5, maybe 10, 12:20 the class is over. If even if you join by 12:30, no problem, right? Even some network issue or something, but you are joining by 12:40 means 25. Vijay Kumar, Vijay Kumar, Vijay Kumar, are you there? So, okay, I'll continue meeting. Right. So here, so complementary function part, no problem. Okay, we can directly do it, right? But particular integral is very, very important. So here also you can see, here everything is a nice one because it is in d square format only, right? So d square is there, d dash is there, d dash square is there. So we can substitute the here minus of 2 square, and here in place of d dash you can put minus of 1 square, right? So they simply substitute as it is, as per the rule they are substituting, and then they are getting the value, but unfortunately they get the value 0, right? They get the value 0, right? Now what we have to do, that is very, very important, right? Just like in the exponential function, here also we have to do the same thing. Multiply x in the numerator and differentiate denominator with respect to d. Differentiate denominator with respect to d. And then if you differentiate it, what will happen? This is become 4d, and this is minus 5d dash, and this becomes 0 because here d becomes 1. So this minus 5d dash is there, that will come here. Then for 2d dash square, it become 0 because we are differentiating with respect to d. So in that case, d dash is like a constant, becomes 0. So now in the denominator we have 4d minus 5d dash, right? But unfortunately again we can't substitute. Now it is denominator is not 0, but we can't substitute because we can substitute only for d square term, d dash square term, and dd dash term, not for d dash in whenever the right hand side in the trigonometric form. If it is in exponential form, we can substitute, but it is in trigonometric form. So what to do? How to make it as dd dash? For that, there is a standard procedure is there. You have to multiply the numerator and denominator, right? Now you have to multiply the numerator and denominator with respect to the conjugate. Conjugate means, suppose if it is 4d minus 5d dash means you have to multiply with 4d plus 5d dash. Suppose here if it is plus this there, then you have to put minus here, right? And then if you multiply and divide this term, then you will get, see, this is 4d minus 5dd dash, and this is 4d plus 5dd dash. So both the terms are in the denominator, and this is something like a minus b into a plus b format, a minus b into a plus b, right? It is in the form of a minus b into a plus b in the denominator, right? So everybody knows what is a plus b to a minus b. What is a plus b into a minus b? Somebody repeats. What is a plus b into a minus b? Hmm. What is a plus b into a minus b, man?
A square minus B square.
A square minus b square, right? So in place of a, 4d is there. In place of b, 5d dash is there. So here a square, that is 16d square. Here b square, that is 25d dash square. 25d dash square, right? And now it is eligible to substitute. So in place of d square, you can substitute minus of 2 square here. And in place of d dash square, you can substitute minus of 1 square. That you can do it. And now you can get a nice number, minus 64 plus 25. You will get a nice number, 39. But in the numerator, we have 4d plus 5d dash. So you can multiply. So this is something like a operator. Remember, even though we are multiplying, dividing, all this they are doing, but d, d dash are all numbers. They are operators. So 4d of sine 2x plus y, that is first term. Then 5d dash of sine 2x plus y, another term. So here 4 is a constant, no problem. So d of sine means differentiate sine with respect to x one time. That is the meaning. So if you differentiate sine, you will get cos 2x plus y. Since 2 is here, so you can write 2 here, right? It is something, differential of sine ax is cos ax into a. That a is this number 2. That is coefficient of x. Similarly, differential of sine ax is cos ax into a. So here a means, since you are differentiating with respect to y, here coefficient of y is 1. So you have to multiply this with only 1. So it is cos 2x plus y. So now the problem over. This is 4 times cos. So 4 into 2, 8. So 4 into 2, 8 times cos. There 5 into 1, 5 times cos. So 8 plus 5, 13 times cos. 13 times cos. Right? So you are getting the nice answer here. You are getting a nice answer here. Right? So this is the final solution. You can take it as the complementary function plus particular integral. So complementary function is this one, right? And the particular integral is whatever you are found in the last one, that you can here. So adding complementary function particular integral gives you the final solution. So these are the two cases. One is the right hand side is exponential. In that case, if the denominator becomes 0, what do I have to do? That we have seen. Right? Directly we can multiply x power r by r factorial, or we can use the same method what we have seen now. Multiply the numerator by x and differentiate the denominator with respect to d. Right? That we can do. Right? So there is one more thing also there. The right hand side is in algebraic form. So algebraic form means it is in x square y square format. It is in x square y square format. So you can see here x cube y, right? X cube y, right? So if this the right hand side is in algebraic form, that is in the polynomial form, then what you have to do, right? What you have to do here, you have to use a procedure called binomial expansion procedure. For that, you have to write the denominator in the form of 1 minus x format, in the form of 1 minus x format, right? And then you have to take this 1 minus x, the numerator, and then you can do the things. So you have to write the denominator in 1 minus x format, right? So here you can see the denominator is nothing but the d square minus 2dd dash. How to make it 1 minus x format? Take the first term out. So automatically it becomes 1 minus 2 times. So since you take d square out, so denominator is d square. But since the denominator d square, but already 1d is in the numerator. 1d is in the numerator. So that d and this d square cancel out. So we'll get 1 minus 2 dd dash in the denominator. So now this 1 minus, right, 2 dd dash is in the format of 1 minus x format. 1 minus x format. You may ask why we are writing like this, sir. In the next step you come to know. Right? So now we don't bother about the denominator. We take the term which is in 1 minus x form in the numerator, and then we can write the same term with power minus 1, because it is comes from the numerator, from denominator goes to numerator. So 1 by x can be written as x power minus 1. In the same way, right, they are written like this. and then we have to write the expansion. So here I will just explain you. Okay, you can see the binomial expansion right in any formula book, even in the Google search you can search, it will come, right? 1 minus x power minus 1 is 1 plus x square plus x cube. This is the expansion of 1 minus x power minus 1, right? Similarly, the expansion of 1 plus x power minus 1 is, that is here, come here plus, right? Then it becomes 1 minus x plus x square minus x cube. Same expansion but alternative sign. Plus minus sign comes alternatively, right? But if here also minus, then if it is comes everything plus. So here in our problem it is minus here, so we'll get 1 plus, in place of x we can write 2 dd dash. So this whole term we call it as x, right? Then d square means you have to square this term, it becomes 4 d dash square by d square, and then it goes, it is an infinite binomial expansion, but we stop with d square. Why? Because, right, you can see the polynomial. What is the polynomial? It's a third degree polynomial. So whenever a polynomial is there of suppose order 2, right, if you differentiate one time it becomes 2x, if differentiate second time it becomes 2, if you differentiate third time it becomes 0, right? So similarly, right, so here, even though this given series is an infinite series, but writing the terms d cube d power 4 is immaterial, because this given term, if you multiply this d dash with this term, we have to differentiate this term with respect to d dash and with differentiate with respect to d dash square. So differentiation means after some differentiation, automatically polynomials become 0, right? So here, when you see the function, it is only x cube y. It is only x cube y. So when we apply d dash on x cube y, so you have to differentiate x cube y with respect to y. That is because it is d dash. One time it becomes x cube. It becomes x cube. And second time if you differentiate, right, it becomes 0. So even the d dash square term is also not necessary. Only d dash is enough, because in the numerator we have d dash term. So d dash term means differentiate the term with respect to it one with respect to y one time. If you differentiate this term with respect to y one time, it becomes x cube. Suppose if you take d square term also, then it says differentiate the term with respect to y 2 times. So if you apply d square terms, d dash square terms here, automatically will get 0. Why? Because when you differentiate with respect to y one time, it becomes x cube. Second time it becomes 0, because you are differentiating with respect to y. So even we don't need this, right? So you take only this part, right, first two terms, and we write this one 1 into x cube y, that is x cube y, and then 2 as it is, then d dash by d times x cube y, right? So first you have to apply the numerator first, then denominator. So when you apply the numerator first, it is d dash x cube y. That means differentiate x cube y with respect to y one time. Then you will get nicely x cube, right? Now you take the denominator term inside, because this d square is already there. In the beginning we take this d square outside. That term you can take inside. So 1 by d square of x cube y, it is not x square, it is x cube, right? It is x cube y. So here also x cube y plus 2 by d square into d becomes d cube of x cube, right? So 1 by d square x cube y, then 2 by d of, right, 2 by d cube. D cube means this d square d become d cube, and this x cube in the numerator. Now what is the meaning of this? Again I told, if d is the differential operator, 1 by d is the integral operator. So 1 by d square means integrate 2 times. 1 by d cube means integrate 3 times. So what will happen, right? Just listen. If you integrate x cube y one time, with respect to x, that is very, very important, because 1 by d means it is dx. If it is d dash means it is y, but it is 1 by d. So you have to integrate with respect to x. So if you integrate this one time, it becomes x power 4. X cube becomes x power 4 by 4, and y as it is. That only they written here. But that is not the end, because d square term. So you have to integrate again. So again, if you integrate, you will get x cube by pi in the denominator. Already 1 4 constant is in the denominator and y. That only they written here. X cube by 5 into y by 4 into y by 4. Right? So differentiating x cube y term 2 times with respect to, sorry, integrating x cube y term 2 times with respect to x. Now here, same thing you have to do. Integrate x cube terms 3 times. So if you integrate x cube term 3 times, what will happen? One time if you integrate, it become x power 4 by 4. Next time if you integrate, it become x power 5 by 4 into 5, because this 4 is already there, 4 into 5. Again if you integrate, because you have to integrate 3 times, d cube means 3 times you have to integrate the numerator. Again if you integrate, it become x cube by 4 is there, 5 is there, and then 6. And now this is 6 4 6 5 are 30, 30 4s are 120, but numerator 2 is there, so 2 by 120 is 60. That is here, right? So in this manner, we can solve the problem. Here denominator won't be 0, because here we are only applying the binomial expansion. So here the denominator won't be 0. Only thing is you have to write the denominator in binomial series format, in the binomial series form, that is 1 plus x or 1 minus x form. Then you will take this term in the numerator, and then we do the binomial expansion, and then we stop wherever we want. So if it is only y is power 1 and we are differentiating with respect to d dash, means only one time. Suppose here y power is 2 means we can go up to d dash square. Suppose y power 3 means we can go up to d dash cube also, right? It all depends on what is the power, right? So you can, in all examples, you can do up to 1 2 terms or maximum 3 terms, right? Then you have to do the differentiation. After differentiation, you have to take this denominator term inside and you have to do the integration. Then you will get a nice particular integral. Then your final solution is complementary function plus particular integral, right? So these are the three things. That is, right hand side is exponential form, or right hand side is in trigonometric form, or right hand side is in algebraic form, right? Suppose if two things are in addition, right? Suppose here what is exponential form, another one is trigonometric form, right? You have to take this as particular integral 1 separately and this as particular integral 2 separately, and you have to find particular integral 1 separately first, some value as it is for e power 2x, substituting d equals to coefficient of x and d dash is coefficient of y. Since there is no y, d dash becomes 0 and you get a nice number, and then you take this as particular integral 1 and particular integral 2, and final solution is complementary function plus particular integral 1 plus particular integral 2, right? Provided both the things are in addition. This is very, very important. Suppose if an exponential function is multiplied with any other function, either trigonometry or polynomial, right? Like this, right? You can take only 2 minutes to finish stuff, right? Like this. See, here it is not plus, it is in multiplication. What is the meaning? Exponential function multiplied with a trigonometric function. Here, what is the workout procedure? Here, what is the workout procedure? Right? I will tell you. Well, I take a nice problem. I will explain. I'll take this itself. Right? Oh. If it is in multiplication, I will tell you one simple idea, right? Because that is there in the Virarajan book also. Okay. So I will take that one. Oh. Right? So only 1 minute. Okay, so I will take only 1 minute, right? I'll finish it off. I'll give you one simple idea, right? So in this thing, right, they give the particular integral in separate one, particular integral 1, particular integral 2, and then they work it out, right? But there is an alternative method is there, right? There is a alternative method is there, right? That I will explain you now, right? So just listen carefully. Suppose if you have a right hand side like this, suppose for example if this right hand side is d square minus 2d dash, and in the numerator if it is like this, e power 2x plus y 2x plus y into x square y square, right? In product, right? Not addition, it is in product. Then what you have to do, no, very simple thing is that in book they are putting so many things, but right, the simple idea is that what you have to know, whenever an exponential function is multiplied with any polynomial or trigonometric function, whether it may be x square y square or it may be sine of something, no problem, sine of something or cos of something, no problem. Whenever it is in product, you do one simple thing, right? change d as change d as d plus a. I'm not asking to substitute, I'm asking to change, not substituting d equals to a. Change d as d plus a. For example, here, what is the value of a? That is coefficient of x is 2. So now, in the original denominator, in place of d square, you have to write d plus 2 the whole square. Similarly, in place of d dash, right, you can substitute you can substitute d dash plus 1. What is d dash plus 1? Right? What is d dash plus 1? D dash plus 1 is nothing but the coefficient of y. Since the coefficient of y is 1, so we can write d as d plus a and d dash as d dash plus b. One, you have to do once this simple thing, right? And then you can expand this. D plus 2 whole square is d square plus 2d plus 4 and minus 2d dash, and then you can write it in a single format. Once you write, then you take this exponential term in the left hand side, e power 2x plus y in the left hand side. Once after the substitution, what you have to do, in place of d, you have to substitute d plus a. In place of d dash, you have to substitute, right, and d dash plus b, right? Once you substitute this, right, you can take this e power 2x plus y on the left hand side, and then hereafter whatever the right hand side, whether it is x cube, x square, y square, or sine, whatever it may be, you proceed as it is, just we have discussed now, right? If it is in x square y square means you have to write it in the binomial format and you have to expand it and you have to do it. If it is sine or cos term means you have to substitute for d square terms, d dash term, or d dash square terms, and then you follow on, right? So whenever an exponential function is product with an algebraic function or trigonometric function, a simple thing, no need to do whatever, because in book they put a little bit bigger. Very simple thing I know, because this is alternative method given in the Virarajan book. So this I discussed in the offline class. So you have to replace d as d plus a. D as d plus a means in place of d you have to substitute d plus coefficient of x, not putting d equals to 2, not like that, d plus 2. Similarly, d dash plus coefficient of y, and then you take that exponential term in the left hand side, keep it as it is, and write it in the final solution. Hereafter, it has no rule in the denominator. Whatever in the right hand side, that you have to substitute and you can do problems, right? So because of this tight schedule and we have only 2 classes, online classes, right, and we have only 40 to 50 minute schedule, right, I am little bit faster, but anyway, right, you can ask all the doubts. Whenever you have a doubt, you can ask me. And also I already shared this type of handwritten notes also there, and I also shared the previous class lectures also in the GCR. So you try to read again and again, and if you have any doubt, you can ask